Hi and welcome everybody. Thank you for attending this webinar on 3D printing and Cinema 4D. My name is Paulo Kiefe. I'm the CEO of Creative Tools and an avid user of Cinema 4D and 3D printers, two things which I really love to combine. I'm going to talk to you about 3D printers. I'm going to show you a short example, and I'll be co-presenting this webinar with Johan Bernd at Maxon, who also is an avid user of 3D printers. So let's look into the contents of this webinar. I'm going to briefly talk about 3D printers and 3D printing. I'm going to let you know about the benefits and limitations of this technology. There's some best practices for 3D modeling in Cinema 4D I would like you to learn. Johan Bernd will then show his quadcopter design, and I'll be making a lampshade in Cinema 4D. I must point out I'm not a lampshade designer. This is just a fun project I made to show you the technology. And then we're going to talk about 3D printing bureaus and repositories. And at the end there will be time for questions, so please submit your questions. I will answer any questions you have. I can also mention that I will make the files for the lampshade available for download. So if you like it, you can just grab the files and start printing. I'd like to start and try to explain what a 3D printer is. I define it as a machine that uses digital models to automatically produce diverse real objects. So it doesn't need human interaction while it's working. So once you start it, it will create from start to finish whatever you want it to make. And it doesn't need retooling to make different objects. So this combination is really powerful. So when should I use a 3D printer? If you want to make many objects, identical in size, shape, and material, a 3D printer is not really very effective, because what you really want to do is mass produce stuff. But let's suppose you want to make any kind of shape whenever you want. A 3D printer is the perfect tool for that task, because that will allow you to do mass customization. In this slide, I would like to explain the basic anatomy of 3D printing, which is quite simple. First, you create a 3D model in Cinema 4D as usual, and then you export the object you want to print as an STL file. You then open the same file into a slicing software which usually comes with the 3D printer. The aim of this slicer is to literally slice the object along the z-axis and cut it into many thin layers. All layers have the same height and are described sequentially by the slicer as separate two-dimensional images. These are then compiled into a print file that instructs the printer to start making the object one layer at a time. This file can be sent to the printer via USB cable, Wi-Fi, or simply copied onto a flash drive, which is then inserted into the printer. Let's describe a few benefits of 3D printing. The most obvious and traditional use is making prototypes. In product development, tooling costs are really high, so whenever you can 3D print a part that lets you understand your design is wrong, then you can save a ton of money making the mistakes low cost. 3D printing allows anyone to make unique objects. As the adoption of consumer-level 3D printer expands, people are beginning to realize that they can create their own products and make them special. Even though the objects are made by a machine, the results have a handmade aspect to them. Imagine if you show a friend something cool you 3D printed and they ask you where you bought that, then you can tell them, I didn't. I just made this in Cinema 4D a few hours ago. Another good use is repairing consumer products by printing spare parts, but also improve them and making them stronger. Who knows, maybe in the future manufacturers will be able to supply downloadable spare parts so customers can repair their products at home. 3D printers can easily improve the life of a person with disabilities. There is an inspiring collaborative development happening around the world. One such I recommend you to see is enablingthefuture.org. Maybe my most favorite benefit for 3D printing is teleportation. Even if it's in a simple way, you could literally 3D model or 3D scan an object in one part of the world and immediately have it materialize somewhere else on this planet. There are so many more benefits than I can fit into this slide, but I think the most important one, the one that joins all these together, is that a 3D printer allows you to create stuff you can't buy in stores. And apart from that, it's just plain fun. Very often people ask me, what can you make with a 3D printer? So here's a short list of things. You can, for instance, make toys. They're usually made of plastic anyway. You can make decorative stuff. If you have something that you want to improve the performance on, you can hack that. And if it's broken, repair it, as I mentioned before. If you can't find things in stores, contemplate designing it in Cinema 4D and 3D print it instead. And if you're happy, share the file with someone else. Jewelry is becoming more and more popular both as a hobby but also as a professional industry. You can make miniatures, you can make gadgets, and the list goes on and on. There are obviously also situations where a 3D printer is not the best tool. For instance, if you design something that can hurt yourself or someone else, if it breaks or fails, you shouldn't use a 3D printer to make that part. Any object with very thin features and very complex shape will be difficult to make. And a big no-no for 3D printing is to make food containers, because you never know how the food will react to the plastic. And generally speaking, sometimes I have to remind myself that 3D printing is just another tool in the shop, and that good old common sense will keep me safe. So let's dive into a few best practices for 3D printing with Cinema 4D. The first I want to mention is that you should always design in real world scale. So whatever you model in Cinema 4D needs to be the same size as the intended 3D printed object. So make sure to go to project settings and adjust the scale units to millimeters if you prefer the metric system. In the same dialog, you can also rescale the whole scene if you realize the scene is the wrong size. This is for instance very useful if you have an old scene and want to make it the correct real world size. The next thing to remember is to avoid making shapes that are too small to 3D print accurately. Keep small features to 0.5 mm or larger. If you're unsure, use the measuring construction tool in Cinema 4D to size your object, and don't forget to press the letter P on your keyboard and activate vertex snap. A very important issue when modeling for 3D printing is to make sure that the mesh does not contain any errors. One such error is when polygons are inverted and inside out. In a healthy mesh, all the surface normals should point outwards. To see the current surface orientation, you can select normals in the options menu of the editor window. If you see any inside-out polygons, just select them, right-click and choose Reverse Normals. Cinema can also make this easier for you if you select all the polygons, right-click and then choose Align Polygons. This will make sure that all the normals have the same outwards orientation. Another common error is the occurrence of holes in a mesh. For 3D printing, it's important that a mesh is watertight and has no boundary edges. An easy way to check your object for holes is to activate the modeling mode in the attribute window. Then choose a tab called Mesh Checking and select Boundary Edges. This will highlight any holes in your meshes, and then you can proceed to close them with your standard modeling tools. The reason why it's important to avoid mesh errors is that the slicing software will not understand the geometry of your object correctly, and this can lead to failed prints. Contrary to the real world, objects in 3D can collide and overlap, resulting in negative internal voids. This is something that slicing software has difficult to understand and can lead to failed prints or weakened errors in the printed parts. If a model has such voids, you can fix them by joining all parts into one watertight volume using the Bool Union tool in Cinema 4D. Unsupported surfaces is probably the most common challenge with 3D printing. When designing your objects, take this into account and orient the models in the most appropriate way so you avoid steep overhangs. In this image, you can see that the two shapes are exactly the same model. The left one is impossible to print without support structures, but just by rotating it 180 degrees, the model no longer needs any supports and prints easily. When you realize that your model is far too complex to be 3D printed easily, then it is time to start cutting it into several pieces. These can then be printed separately and glued together. Just by looking at the shape, you can often find a parting line defining the optimal split. The holy grail of 3D printing seems to be multicolor objects. There are several technologies that allow you to achieve this, but there are far too many disadvantages involved. My best advice to anyone who wants to print objects with colored parts is to separate them with Cinema 4D and 3D print them individually. These can then be put together with glue or snap fit joints. Doing so gives you far more advantages than a single 3D printer with color features can give. The most obvious setting in a slicing software is to adjust the layer height. Thinner layers create objects with smoother surfaces, but they also take much longer to print. My hint to you is to prefer thicker layers, because they will not only create your printed part faster, but also make it much stronger. Regardless of what 3D printer model you use, there will always be situations where the maximum build volume is too small. The best solution to this problem is to split the object into smaller parts. Very large objects are quite demanding to make, So therefore it's much easier to print two halves of a large object than the whole thing in one go. Any manufacturing method is affected by dimensional tolerances, and so are 3D printers. Sometimes features print slightly too small or too large. If you want to adjust the size of a feature in your model, you can first make a test print and then measure the size of the hole or gap. You can then use the normal move tool in Cinema 4D to move the surfaces along their normal directions. This will let you quite easily shrink or grow the size of a feature and compensate for the value. Earlier I mentioned that thicker layers yield stronger parts. It's also important to orient the part on your 3D printer so that the layers stack in the optimal direction according how your part will be subjected to forces. Think in the same manner as you would do with wooden objects. If you need to split a model for 3D printing, my advice to you is to think like a traditional carpenter. There is a vast amount of literature on this subject and you can easily go to the library to learn more. My preferred jointing method is to create coaxial holes in each half, and then use dowel pins to secure the parts in place when I glue them together. A quick tip here is to make the holes slightly conical. If you don't want to mess around with tacky glue, you can also use a soldering iron for electronics. Just set the temperature at 200 degrees Celsius and then you can literally melt the two parts together to create a very strong bond. Here are a few hints on how to deal with overhang surfaces. If you keep the section profile of your model to an angle of roughly 30 degrees, then you can probably print the object without the need of support structures. If the angle is smaller than what your 3D printer can achieve, then you can choose to let the slicing software automatically create support structures. The more complex the shape, the more support structures will be needed. Remember that just by changing the orientation of the object, you can reduce or eliminate the need of support. I'd like to talk a second about materials. Popular 3D printers today use plastics to create models, the most common being ABS and PLA. ABS derives from the oil industry and is used in most injection molded products such as toys, household items, gadgets, and so on. PLA is a plastic made from plant-based materials and is therefore a better choice from an environmental point of view, but it also prints beautifully and it's very easy to use. The polymer industry is now gaining interest in supplying a variety of different materials for 3D printers. Now it is possible to print objects that are flexible as rubber. There are materials containing wood and metal particles, and there's also plastic that dissolves in water, which is perfect for support materials. I will now leave the floor to Johan Bernd, who will tell you more about a real-life project in which he used 3D printing.
Thank you, Paulo. Well, about a year ago I got addicted to a new hobby, namely building and flying multirotors, but sadly enough I was grounded during winter time, mainly due to water and snow, and I noticed that it didn't really mix with electronics, so I had to come up with a high-end indoor solution that would give me the same frills as my fully fledged race quads. Now, even though it would probably annoy my girlfriend to no end, but what are you gonna do? So 3D printing allowed me to quickly come up with an initial frame design, even though I was still waiting for my ordered parts to arrive from the slow boat from China. So once the hardware components arrived, I quickly realized that the online specifications and measurements were incorrect. But designing and 3D printing the frame in advance allowed me to perform some initial stress testing and weight reduction. And once all parts arrived, I redesigned the frame once more according to the actual measurements. So this is the final prototype for the 3D printed frame, and I used it to test the flight performance and strength of all the components combined. As you can see, the maiden flight was successful and its flight characteristics were excellent. And the 3D printed frame was strong yet light, but I wanted to take it one step further. So all my frames are made out of carbon fiber sheets, since it is a very durable material, and I contacted several companies to see what a CNC frame would end up costing and what file format they required. And luckily I could use the same 3D model I constructed in Cinema 4D and that I used for 3D printing to export a DXF file that was accepted by the milling machine. So once I received the carbon frame, everything fit together very nicely without any issues, and that is thanks to rapid prototyping and 3D printing. I did not waste any expensive materials such as carbon fiber sheets, and the total cost of the frame ended up being just €35. And you can compare that to similarly sized commercial frames that usually cost around €70 or even more. But the big difference is, of course, that this is a completely custom built frame that suits my personal needs. It is fast, it protects my furniture and pets from the fast spinning blades, and can be flown both indoors and outdoors. So this is just one example of how I use my 3D printer, and I fire it up at least once a week to print everyday items. But let's take a look at another example that has been built from scratch in Cinema 4D, namely a lampshade. Paulo, the stage is yours.
Thank you, Bernd. For this webinar, I wanted to create a common household item modeled in Cinema 4D and materialized on a home 3D printer. So I came up with the idea of making a simple lampshade, and here's what we have to start with. First, I measured a standard lamp fitting. The washer holding the lampshade is about 30 millimeters in diameter. So in Cinema 4D, I created two objects, the actual lampshade itself and a structure to connect it to the lamp fitting, close to the light bulb. The second criteria is the actual 3D printer and its features. I chose the FlashForge Finder because it's a consumer-friendly, easy-to-use machine. It's very compact and affordable, it prints using PLA, the plant-based plastic, and it's Wi-Fi enabled, and it has a proper color touchscreen. In other words, it can be used by anyone who likes 3D. You don't need to be a 3D printing geek to be able to use this machine. The FlashForge Finder has a maximum print volume of 140 millimeters in X, Y, and Z, and I found this to be a really nice size for a lampshade. Obviously, as I mentioned before, if you need larger parts, you can still split them into smaller sizes and glue them together afterwards. We are now finally inside Cinema 4D, and here's a short time-lapse video of the modeling. The first thing I did was to make sure to use millimeters in the project settings. Then I made a cube as a visual representation of the Finder's build volume. This made it easy for me to stay inside that shape. I then used the cogwheel tool to make the shade fitting and size the center hole to 30 millimeters in diameter. I continued with the cylinder and then deformed it with a taper object to achieve a rough shape of the lampshade. To create some surface features, I simply used the Mow Extrude tool under the MoGraph menu. After some fiddling around with the settings, I was happy with the shape, and then I exported both objects to the STL file format. These are now ready to be opened into the slicing software and 3D printed one at a time. As I mentioned before, the file exported from Cinema 4D needs to be opened in the slicer software before it can be printed. Here you can see how I started by slicing the lampshade fitting using FlashPrint, which is a standard software that comes with every FlashForge printer. It's very easy to use and has predefined quick settings, which are good for most print jobs. But for a tech geek like me, there's an advanced mode with lots of features to play around with. Since the FlashForge Finder follows an open standard for 3D printing, the machine can be used with third-party slicing software. To demonstrate this, I imported the lampshade into an open source software called Slice3r, where I created a profile based on something called a vase mode. This will affect the printing of the shade in such a way that only the outer contour is printed, and it does so in the shape of a continuous spiral. This creates a thin-walled, seamless surface, which is perfect for making a lampshade. It's time now to enter the physical world and start melting some plastic. Here are some videos for me to demonstrate how the printer works. The first step is to load material into the Finder, and this comes as a spool loaded with 600 grams of PLA plastic filament. A flexible plastic tube then guides the material into the printhead, where an electric motor grips the filament and then pushes it down into the extruder. The next step is to use the touchscreen instructions to load filament. This will automatically heat up the printhead to its target temperature, and then the feeding motor will start turning. I then inserted the tip of the filament into the extruder until the motor grabbed it and started pulling it down. After a few seconds, the melted filament comes out of the nozzle at the lower end of the print head. As you can see now, this kind of 3D printers more or less resemble a high-tech glue gun. The Finder is now ready to print the files I sliced earlier. I saved them to a standard USB flash drive, which I then inserted into the printer. Then I use a touchscreen to select the file and tell the printer to start making the lampshade. The current video showed a few seconds of the Finder printing in real-time speed. I then sped up the video to a time lapse, compressing the total 90 minutes it took to print the lampshade. When the print was finished, I pulled out the build plate and removed the lampshade carefully using a standard box cutter knife. Here you can see how I put the lampshade onto a standard light fixture. It's a quite straightforward process, and the shade attaches to the star shape fitting just by friction. I also want to mention, if you do this at home, please make sure to use LED lights. These are safe to use because they don't generate enough heat to melt any plastic. And here's the result. The lampshade standing on the windowsill. I must say that I've used 3D printing for almost 15 years now, and I still get a kick out of seeing what I've made in my computer turn into real objects that I can touch. And by the way, if you like this lamp, you can download it today. Just go to the webpage below and get it. Apart from the STL files, you can also download a C4D scene file, and feel free to modify it in any way and share with other people. Being able to make your own stuff at home is quite nice and empowering. But what about costs? Apart from the actual investment in the 3D printer, which in our case is a Flashforge Finder for €4.99, the cost per print is very low. PLA filament costs roughly 4.5 cents per gram. The lampshade and its fitting weigh together 51 grams, which yields €2.30. So it is by far cheaper than going to the store and buying a standard lampshade. Three D printing has been around for decades, but relatively few companies and individuals own a 3D printer. Traditionally, a large part of the supply of 3D printed parts has gone through specialized companies, so-called 3D printing bureaus. Customers can send their 3D files to those bureaus, where they pay for a service. Then they get the printed parts shipped back to them. Here I'm going to explain the advantages of both owning a 3D printer and also sending files to printing bureaus. If you have a 3D printer in your home or office, you can print whenever you want and whatever you want. You know exactly when your print will be ready, and you will also be able to print prototypes without external parties being involved. This also makes the production cost totally transparent. Sending away your files to a 3D printing bureau has some nice advantages too. You don't need to own, run, or service a 3D printer. You can choose from a wide variety of 3D printing technologies and materials, and you can very easily scale up the production of parts with no extra effort. Printing at external printing bureaus is commonly more expensive per part, and you will be dependent on their production schedule in regard to when you get your part delivered. As I see it today, owning a 3D printer and also sending out files to printing bureaus is the most powerful way to 3D print. Both complement each other perfectly. On a side note, we all know that the potential of crowdsourcing can be enormous. A few years ago, a company called 3D Hubs was launched. It is an online 3D printing service platform that operates a network of 3D printers with over 20,000 locations in over 150 countries, providing 1 billion people access to a 3D printer within 10 miles of their home. Anyone who has a 3D printer at home, or even companies, can register and earn some extra cash by providing localized 3D printing services. Most people who haven't been introduced to 3D printing yet have probably not heard about online file repositories for 3D printable objects. But I'm quite sure that these will become extremely popular in the near future. I am, for instance, quite addicted to these websites and visit them every single day. In a nutshell, these places are becoming social media for people wanting to make and share physical objects. Anyone can register and upload their 3D files, as well as download, comment, like, and reshare other people's files. One of the oldest and by far the most popular is Thingiverse.com, which is owned by the 3D printer manufacturer Stratasys. Two other popular sites are Umagine.com and Pinshade.com, owned by Ultimaker and Formlabs respectively. In my view, there is an enormous potential in enabling people to share their designs with the world and cooperate with other creators. I think that we're just seeing the beginning of this. If you want to see an extensive list of these file sharing sites, please visit 3dbenchy.com/download. And if you want to see the 3D printable files that we at Creative Tools have made and shared, please visit thingiverse.com/creative tools. So this is the end of my presentation. I hope you liked it and that I could inspire you to convert your homes into tiny factories. I would also like to thank the good people at Maxon for inviting me to talk to you about 3D printing, which is something that I really love. And now we can open up for questions so that Johan Brandt and I can straighten out any questions you may have.